Assalamualaikum. And I'm Dr. Mehvish Salman, and today I present my presentations organized by in conference organized by Department of Physiology and Department of Pharmaceutics and Government College University, Faisalabad, Pakistan. And the topic of my presentation is antibacterial, antioxidant, antidiabetic activities of bioactive secondary metabolites extracted from Cucuria oceani. And these are the aims and objectives. Contents of my topic: introduction, objective, scheme of study, method, results, conclusions, references. First of all is introduction. Secondary metabolites are bioactive organic compounds that inhibit the growth of pathogenic microorganisms. Bioactive secondary metabolites are natural products that shows the antibacterial activity against different multi-drug resistant pathogenic bacteria. Actinobacteria produce various types of bioactive secondary metabolites. These metabolites have the potential to combat the variety of pathogenic microbes. The aims and objectives of my presentations: extraction of secondary metabolites from Cucuria oceani, determination of their bioactive potential, antibacterial, antioxidant, anti-inflammatory, antidiabetic, identification of secondary metabolites present in Cucuria oceani by using spectrometry techniques. The scheme of study: growth of bacteria, production of bioactive secondary metabolites, extraction of bioactive metabolites, bioactivities of these metabolites: antibacterial, antioxidant, anti-inflammatory, antidiabetic. Identification of bioactive metabolites by using chromatographic techniques, GCMS and ESIMS. First is culture growth and culture plate scrap and water bath. Next, the culture was centrifuge, and the next step was syringe filter and extraction of bioactive secondary metabolites, and solvent was evaporated by rotary evaporator. Results: Cucuria oceani antibacterial potential of extracted metabolites. The Cucuria oceani bioactive metabolites exhibited potential antibacterial effect against pathogenic bacterial strains Staphylococcus aureus, Escherichia coli, Bacillus cereus, and Serratia marcescens. DPPH scavenging acid, the highest inhibition activity, 83.87%, was observed at high concentration, 600 microgram per ml, and results indicated that the DPPH free radicals inhibited more effectively by increasing the concentration of extracted metabolites. Hydrogen peroxide scavenging acid, the maximum effect of hydrogen peroxide, 91.93%, was observed at high concentration, 600 microgram per ml. Similarly, the anti-inflammatory activity, albumin denaturation acid, the maximum inhibition of protein denaturation, 87.67%, was recorded at the maximum concentration of bioactive metabolites, 600 microgram per ml. And the percentage shows that the response was concentration on dose dependent manner. Similarly, the heat-induced hemolysis, the maximum inhibitory effect on heat-induced hemolysis, 81.39%, was observed at the highest concentration of extracted metabolites. Next, the alpha amylase inhibition antidiabetic activity. The maximum inhibition, 90.97%, was observed at highest concentration of extracted metabolites, microgram per ml, and the dose response, the percentage increase by concentration dependent manner. The glucose uptake by yeast, the maximum effect, 92.77%, was recorded at higher concentration, 600 microgram per ml of extracted metabolites. Similarly, the maximum inhibitory potential was observed at higher concentration and of extracted metabolites. The percentage inhibition of pancreatic lipase was 76.73% at highest concentration. Identification of bioactive secondary metabolites by GCMS, various types of volatile organic metabolites were identified in GCMS spectroscopy techniques, nitrobenzene, beta phenoxyethyl alcohol, pentadecanoic acid, methyl esters, octadecanoic acid, 17 methyl esters, palmitic acid, methyl esters, palmitic acid, methyl ester, and oleic acid, methyl esters, stearic acid, methyl esters, and similarly some other compounds like icosine, docosine, and cyclodocosine ethyl was also present in GCMS volatile fraction. The nature of these compounds, some compounds are aromatic hydrocarbons, and most of the identified metabolites were fatty acids, methyl esters, like palmitic acids, palmitic acid, oleic acid, methyl esters, and pentadecanoic acids, methyl esters. Similarly, some long-chain fatty acids esters were also identified in GCMS chromatogram, and some long chains alkenes like docosine was also present in GCMS chromatogram. And ESI identification of metabolites by ESIMS, some organic acids like succinic acid, glutamic acid, and caffeic acids were identified in GCMS chromatogram, and one drug, magnetol, anti-lipidemic drug, was identified in ESIMS technique. The ESIMS of succinic acid in negative mode. Similarly, the ESIMS of glutamic acid in negative mode, and ESIMS of magnetol in negative mode, and ESIMS of caffeic acid in negative mode. So, to the best of our knowledge, the identified bioactive secondary metabolites have not yet been reported from Kukuria Ushni earlier. And this work represents that the Kukuria Ushni bioactive secondary metabolites have the potential antibacterial, antioxidant, anti-inflammatory, and anti-diabetic potential. Further research is needed to clarify their precise mechanism of action and determination of most effective therapeutic application of bioactive secondary metabolites of Kukuria Oshni. So these are the references, and thanks.